By now you should have already completed the top part of your notes today, which is what's shown on your screen. If you have not done this activity yet, then I would like to pause the video now and do this first before you continue watching. Assuming you've completed the activity, I want to check in with that activity really quickly, and then we're going to do some things to follow up with this. So this was a graph of an airplane that is flying, and it tracks how far it has flown horizontally. So basically kind of how much land distance has it covered. And then it also at the same time is tracking how far above the ground it is. So you were asked some questions about what was happening at different points in the graph. And then you were also asked to calculate some ratios. So that was part D. So you had an example in part D that was done for you, and it said pay attention to the scale of the graph because the graph is not counting by ones. The x-axis is counting by 200s and the y-axis is counting by 400s, so you have to pay attention to that. So if you're finding the change from point B to point C, so that would be from here to here, so it asks you to write the ratio of the vertical up and down change compared to the horizontal change. So the vertical change is right here. So we went from an altitude of 2,000 to 2,400. So that's where we got this 400 feet on the top. And then you're asked to do the same thing with the horizontal change. So horizontal change changed by this much. So it went from here, which is 400, to here, which is 800. Well, that's another change of 400. So that's where we got the bottom 400 from. So you have to pay attention to your units. And then we can reduce that. 400 over 400 is a total change of 1. So it asks you to go through and calculate each of these. So really quickly, to check your final simplified answer. So if you didn't simplify, then you might want to go through and do that really quickly so you can check and see if you're right. So from A to B, our change was 0 because we weren't getting any higher or lower. So B to C, our change was 1. So that basically means for every 1 foot we traveled horizontally, the plane also got 1 foot higher. So from C to D, that one you had to be a little bit careful with because D was kind of in the middle here. So you had to think carefully about what that was. So that basically went from 800 to 1,100. So that's a change of 300. So that one was a final answer of 2 over 3 if you reduce it. From D to E, again, you had to be careful because you were kind of in the middle of 2 points here vertically. Between 2,000 and 2,400 is 2,200. So we went from 2,000 to 2,200. So we increased by 200 feet up and down. And then we increased by, again, 300 feet side to side, which is how we get that 2 over 3. And then E to F, that one we increased by 300 feet up and down and 200 feet side to side. So that would be reduced 3 over 2. So you can reduce those different ratios. So the answer asks you, or the final question asks you to circle the one that was the biggest. Well, that one with the biggest answer should have been E to F. And if you look, that is also the steepest. So that is the steepest part of the graph. It is also, if you look at your ratios that you made and you simplify them, it should be the one that has the biggest ratio or the biggest number. So bigger ratio means steeper graph. So what you're working with these ratios that you're calculating is rate of change. So that is the idea for today's lesson. So we're going to go through and we're going to work with this idea of rate of change a little bit more. So on your graph, we're actually going to go back to the graph a minute. So each of these ratios, so you were calculating as a ratio the vertical change over the horizontal change. So that actually is how we calculate rate of change. So rate of change compares the change in the output or the vertical change to the change in the input or the horizontal change. And it is a ratio. So we always put whatever the vertical or the change in the outputs is first on top. and the horizontal change on the bottom. Now there's one other thing that we can do, and you may or may not have thought to do this on the airplane problem that you were working with, but if you look back at the airplane problem, some parts of this graph were going up, and there was one part of the graph, so right here, between C and D, where the airplane actually lost altitude. So its height decreased. It was going down closer to land during that time interval. So there's a way we can show that with rate of change. So we can show rate of change as either a positive or a negative number ratio. So a positive means that it's increasing. So the airplane is gaining altitude. Now your answer for C to D, you could actually put a negative sign in front of that to show that the airplane is losing altitude. So when we're working with rate of change, we use positives and negatives to tell us or to help us keep track of what's happening. So in that ratio of the vertical, the horizontal change, is it getting higher or is it getting lower? So an increasing rate of change, so where the graph's getting higher, we would represent with a positive number. So your ratio fraction that you make would be positive. A decreasing rate of change, so if the graph is getting lower, we would represent with a negative number. So you're basically doing this calculation on the airplane problem that you did, but I want to look at a couple of examples with you just to reinforce how this works. So a couple of examples. This is a different graph. So this shows quiz scores over a number of time, and it's asking us to find the rate of change from week 2 to week 5. Well, week 2 is right here, and week 5 is right here. So rate of change measures the vertical change to the horizontal change. So the vertical change would be our up and down measurement, while what we're measuring up and down or on the output y-axis is our quiz score. So we're basically tracking our quiz score. So we want to see how much did the graph change this way, the vertical change. So that's going to be the change in quiz scores. So his quiz score went from a 76 when we first started tracking it to an 89 when we ended. So that is a total change of 13. And then we want to find the horizontal change between those points. So how much should I change side to side? So that is going to be dealing with the weeks. So from 2 weeks to 5 weeks. So that's a total change of 3 weeks. So if we were to add units on here, we would say 13, and we're assuming we're tracking our quiz scores in percent. So 13% over 3 weeks. So his score increased 13% over a 3-week time, and the graph is going up, so our rate of change would be positive. So we don't have to actually put the plus sign there, positive number. If there's no sign, we know it's positive. Now, one thing that we could do, if we wanted to, is we could leave this because 13 over 3, that's not a nice fraction. Another option that you could do is you could divide that out and do 13 divided by 3. Or you could change it to a proper fraction, so 4 1/3. So what that's telling you is 13% over 3 weeks, or 4 1/3% each week. So score is increasing by 4 1/3% each week. So that is our rate of change. So far we've been looking at graphs, but I wanted to put a table on here to get you thinking about the fact that you could also look at the data in a table, because we could very easily take the points off of the graph and put them into a table. So the second problem is the same data that would be on a graph, just in a different format. So we just have to think about where things would be. So if we were to make a graph for this, the items, so the number of items would be down here, and the costs would be over here. So if we're trying to find vertical change to horizontal change, our vertical change, or how the graph is changing up and down, is going to end up being the change in money. So we would want to look and see how much the money is changing each time. So if we look at the graph from point to point, you can see that it always changes by 12. So our increase, our vertical change, is 12. And then we want to do that over the horizontal change. So if I'm tracking the change sideways on the graph, that's going to be tracking the change in the number of items. So if I look at this table, that's also very steady. So I'm increasing by 5 items each time. So my rate of change ratio or fraction would be $12 for 5 items. Kind of like we did on the last problem, you could change that to a proper fraction or a mixed number. So in this case, we're working with money, so it might make sense to divide that, because we don't usually track money as a fraction. We track it as a decimal. So if I did 12 divided by 5, that gives me 2.4, which is $2.40 per item. So that's what your rate of change is telling you, is basically how much does the cost price increase for each item. And this graph, if we graphed it, it would be going up. So this is another positive rate of change. So that is what your rate of change looks like. Basically, rate of change is a ratio, and the way you get the ratio is by looking and seeing how much are things changing up and down between whatever points you're compared to how are they changing horizontal side to side between whatever points you're comparing. So at this point, you should have your activity completed from before you watch the video. You should also now have your notes filled in that go with that. When your notes are complete, then you're going to move on and you're going to try the practice assignment for today, which is going to let you try practicing some rate of change calculations similar to what we did in the